Moving on to the data pre-processing. So I have two files. One is the pre-processing IPython file or Jupyter notebook file. Another one is the pre-processing Python file. So let's try to understand what it's doing at the functional level, and then I'll explain what are we doing in the pre-processing Jupyter notebook. So first one is the clean data. So this one, it's coming up with the data frame. So this is the driver from the Jupyter notebook. The call comes to the clean data only. So here we are dropping the loan ID column. So if you look at our data set, the loan ID is just a primary number. Nowhere it's contributing to our model performance. It's just a unique number to identify the record. So we no longer need this loan ID. So I'm dropping off this loan ID. Moving on to the next one. Okay. So once I have that one, I am calling the missing value handle missing. So let's go into that code. So here I'm iterating the data frame columns one by one using for loop. And if the data type is an object, which means it's in categorical column, I'm taking the mode. Okay. So the mode means, let's say we have taken, let's take, okay, the property area. Okay, there is any one of the column is missing. The distribution is the possible values for the property area is or semi-urban, urban, rural area. These are the possible value. So in case if any row doesn't have any value for this column, we'll replace with the semi-urban because the distribution is more for the semi-urban only. Okay. And if it is a numerical column, I'm taking a median. So let's go into, let's say, co-applicant income, or let's take applicant income. So if any one of the column is missing, so the minimum range for the application income is 150 to 81,000. So I'm just taking the median. Median is nothing but an average. So I'm filling the missing value with the median. So in the CKD example, chronic disease example, I have dropped all the column. So here I don't want to drop the column. I just wanted to do the different pre-processing. That's why I did the pre-processing with the median here. Okay. So once we have the data, cleaned data set, okay, moving on to the encoding. So if you look at our data set, here we have the numerical column as well as the categorical column. When I say numerical column, that holds a numerical value like number. When I say categorical column, it means that has a text. Okay, so the machine learning program can perform well rather the number rather than a English description. So what we are going to do is wherever we have the numerical categorical column, we convert those into yes or no value, something like that. So yes means it's 1 and 0 means no means it's at 0. Okay. So this is our data set. So here if you look at our data set, here we have the self-employed. That column doesn't end with yes. So it's saying no and yes only. But if you look at our cleaned data set, here, okay, self-employed, right? Okay, self-employed. Okay, so here the column name is getting changed with the yes and true or false value. That means, as I explained, true means it's 1 and false means it's 0. So by that way, machine learning can understand and interpret these features very well and perform well. Okay, moving on to the next one. For that one, I used the get dummies. And after the get dummies converted into the column, I dropped the loan status column as well, which is not needed because this is the target feature. Okay, this is what we are going to predict, whether the loan can be applied or approved or not. So once the data set, everything is completed, I use the split scalar. So the importance of the split scalar is machine learning loves to deal with the number. So if we have any number, it should not confused with the highest number. So if, for example, let's say we have Okay, let me take a unclean data set. So here we can see the data spread is minimum is application income is 150 to 81,000. So the standard scalar is nothing but taking a mean for this feature. Okay, so just simple example to understand the standard scalar. Let's say we are measuring a height. We can measure the height in different way with the centimeter and the feet. So the feet can be like 6 and the centimeter can be like it can go to 2 digit and 3 digit. So standard scalar means we have to across the board, we have to follow the unique measurement. By that way, we can say by looking at the number, we can say which number is the highest number. So, so that's why we are doing the standard scalar here. So the machine learning program, we already have the pre-built-in function that take care of the scalar. Just we'll have to call that method. So from here, I am passing the x train, x test, y train, and the y test. I just want to highlight few things. So with the given data set, we split the data set into two pieces. One is the training data set, another one is the test data set. Training set set is for training the model. Test set is for evaluating with whether the model is performed or not. Okay, that's why I use the pick transform and the transform. So here we just need to use the transform because we don't want it to whatever the machine learning algorithm applied with this pick transform, the same thing goes to or applicable for the test data set as well. That's why we'll have to always use the transform only for the test data set. Okay. So let's go into the pre-processing. So here in the pre-processing, first I defined at the system path and all to fetch the Python file from the source folder. Once I have that one, I'm just re-importing it, all those things. And here also I have used Python config to store the output in the Parquet format and fetch the Parquet file from the data collection process. So the targeted column or feature is the load status. So here I loaded the data frame from the raw Parquet. I'm just receiving the value in the data frame. So once the data frame is available, I'm passing this one to the clean data set. It's returning back all the training data set, clean the data set, everything. And then I am saved the clean data set as well as the standard scalar set into my Parquet file. So okay, so in this is the file we can see. Okay, in the next module, we will see how we can do the univariant and bivariant analysis. Thank you.